Okay, we've got here is a January 2008 edXL exam. Okay, we're looking at the first question, which is about the trapezium rule. Okay, we've got a curve. Okay, like this. It's given by this equation here between the region 0 and pi. Okay, and we're looking to use the trapezium rule to find the area in that region. And the first part of the question is just telling you really to calculate y for these two values of x. I mean, always with the trapezium rule, you're going to calculate y for some values of x, and then you're going to build up little trapeziums for the area of each section, as we'll look at a little later down. And that's how we do it. And that's what the second part's about, is just applying the rule there. So for the first part, we're going to put x equals pi by 4 and x is equal to pi by 2 directly into this function here. Okay. So x equals pi by 4 is going to go into there and into there. Okay. And really, you just run that out on your calculator to get that answer. And similarly here, putting x into there. Okay, and x goes into there, exactly as you think it would do. And here I'm just noting that sorry, sine of pi by 2 is equal to 1. So if it saves me a bit of calculator time, I don't have to put root sine of pi by 2, because I know sine of pi by 2 is 1, so root of 1 is 1. Okay, we have a quick derivation of the trapezium rule, because it's quite straightforward, and we've got a bit of time, so we can do it here. So we're looking at each element here. So this is xi plus 1. That's the height. That height there would be f of xi. Okay, that height there, f of xi plus 1. Okay, now the h bit is this distance here, which you can see, it's just your xi plus 1 minus your xi. So wherever you are, the difference between the xi plus 1 and the difference between the xi plus 1 and the xi is always constant. Okay, so we take the average of those two. So that's what the 2's there for, and we times it by h. That's the same as you would do really for for any trapezium. That's all it is. Now the next bit, we sum up all the bits of area. So this is what this is doing. It's summing up all the bits of area along the way. Okay. Now we can take the h over 2 out because it doesn't depend on I, and we just sum from I is equal to 0 right the way along to it's going to be n minus 1, isn't it? The way I've written it here, because the next one's going to be n if we do it that way. Okay. So in brackets, if you think about what's happening there, these think about x0 and x1. Okay, then that'll be the first one, and the next one will be x1 and x2, and the next one will be x2 and x3, and you can see that although x0 is not being repeated, x1, x2, x3 and so forth will be, until you get to the final ones, x0 and xn. So those ones are only there once, the rest of them are repeated. Okay, so the sort of standard way of writing it, I suppose, is to say, well, we only get one of these in this summation here, one of each of these, and we get 2 of the rest of them. So that's why that's written like that. That's x2 there, and that's xn minus 1. Okay, that's h divided by 2. All we've really got to do now is plug these numbers in. We know what we know from our table up here. Okay, 0 to pi by 4. I add pi by 4 to get there. That's telling me what h is. That's telling me h is equal to pi by 4. Okay, so h divided by 2 is pi by 8. Okay, at the extremities at x0 and xn, it's 0 and 0. Okay, and then we just put in these middle numbers. So the 2 we calculated here. Okay, and the one we got in the table provided there. And then what you got to do is plug those into your calculators. What I've done is I've taken a step here where I've okay, that's 0, that's 0. I'm going to take the 2 out, so it's only pi divided by 4, and then I've added those together separately. And yeah, so I've taken I've said that's 0, so I can put the 2 outside. Now pi divided by 4, and I've added all these numbers here. That one, and that one. You can see by looking at them, it's going to be about 15. And then okay, it makes sense that it's 12 because it's pi is a bit less than 4, so that all looks right. Okay, hope that was useful. Thanks.